Okay. So yeah. So I partially filled it out on Friday evening, I think. And so that way just kind of give you a little bit of ease you guys into it, kind of like the training wheels if you want to think about it. So if you see something equaling itself, immediately think reflexive. So for number two, immediately when you see that, it's automatically going to be reflexive. When something equals itself. Why we're going to do that, I'll explain in a moment. Oh, you're right. Go ahead. Yeah. Reflexive school. Reflexive school. Yeah. Yeah, here's the reason why. Actually, now let me explain why we're doing that. If you break off the triangles, so that's the small triangle, right? AXY. And then the big one, which is a ABC, looks like this, right? So your goal is to compare both these triangles. When you're comparing both these triangles, you want to show that their angles are the same. So you want to say this angle equals that angle. Well, they're both called angle A. They both come from over here, right? That's why you're saying it equals itself to help you establish that both these triangles are similar. That's why we have to say that. I know it sounds kind of lame because, of course, something equals itself, but you have to state all the pairs of angles that are the same. That's one of your pairs. The other one, actually, it's not a pair of angles, but it's the sides, right? You're told that AX and AB, and then you're told that AY and AC are proportional, right? So AX to AB, AY to AC, that was given, right? So that's why I have to always the first step's always gonna be given. Once you have that established, then we have enough to say the triangles are similar. What is a theorem? SAS. You got to say SAS because the sides are proportional, the angles in between are the same. So of course now I can say triangle AXY is similar to triangle ABC. So that's like the process. Lastly, to say that, oh, well, these sides are proportional, that's because I know it sounds weird. CSSTP, corresponding sides of similar triangles are proportional. CSSTP, corresponding sides of similar triangles are proportional. I know. It'll take some time. It'll take some time to kind of embrace this. Kira, Mhm. Yeah, correct. Yes. Statement is like what you see, what you observe. And why is that true? The reasons why is it true? So it's what you observe. I observe that this is happening. Okay, for what reason? Why is that true? It's true because that was given to me, or it's true because something always equals itself, or the third statement, the triangles. Oh, well, that's true because the sides are proportional and the angle between is the same. Oh, the last one. Oh, that's true because. So it's like you make a claim like okay, like for example, let's say okay, I can make a claim, and this is true. If everyone wants to test me on this, I have all the U.S. presidents memorized from 1 to 46. Okay, I will when I have a chance. But why do I have those memorized? What's the reason? Because when I studied APUSH in high school, that's how I studied. I memorized all the presidents. I haven't forgot after 30 years. So I'm making a statement. You can think I'm BSing you guys. I'm not BSing you guys. I could actually, if someone wants to name a president, actually, good. Hold on. That was, I think, hold on. Hold on. No, I have to do an order. Okay. Okay. Now you put me on the spot. Okay. 16. Okay. Hold on. No, I'm going to do it right now. Okay. 16, Abraham Lincoln. 17, Andrew Johnson. 18, Ulysses S. Grant. 19, James Garfield. 20, Rutherford B. Hayes. 21, Chester A.R. No, yeah, Chester A. Arthur. 22, Grover Cleveland. 23, Benjamin Harrison. 24, Grover Cleveland. 25, William McKinley. 26, Theodore Roosevelt. 27, William Howard Taft. 28, Calvin Coolidge. 29, Warren G. Harding. 30, Hoover. 31, it's got to be FDR, I think. Okay, no, we're gonna go later. Okay, we got George Washington, John Adams, Thomas Jefferson, James Madison, James Monroe, John Quincy Adams, Andrew Jackson, Martin Van Buren,
Wait.
Okay. Well, Donald Trump.
No, the 31st president was Herbert Hoover.
Oh, I was off by one. Okay. Okay. Well, okay. I need to go in order. Okay. Let's keep going. All right. Okay. I can do Super Bowls in order too. All right. All the Super Bowl winners. All the Super Bowl winners.
Who
Yeah.
won that 17 years ago?
So the year, what season? The 2008 season?
Yeah.
Pittsburgh Steelers against Arizona Cardinals. Yeah. 27-23. Yeah. Okay. I'll stop. Now I gotta get up. Okay, I gotta keep my ego in check. All right. What was that? No, that's true. And Hines Ward was the MVP in that Super Bowl. Yeah. I remember watching that game. So the only reason why I like Super Bowls because when I was in middle school, the 49ers were playing really well. And so I was fascinated by that. And ever since I've always followed Super Bowl. So yeah. The 49ers won like several during that time frame. Okay, number 2. Okay, guys, let's get back to this. Okay, now you understand statements and reasons. I'll stop talking about presidents and Super Bowl champions. This is a weird one because the angles are not corresponding. Curious, you have a question?
So like going back to the given and proof, what do you know what to put for 2 to 3? If number 1 is the given and number 4 is the proof.
Yeah, so in this case, yeah, number 1's gonna be given. That's your reason because you're given that, right? Now, when you're comparing the triangles, this is weird. But notice that angle X and angle C are the same. So I have to flip one of them. I decided to flip triangle AXY so that it corresponds or it's oriented in the same way as ABC. So I flipped AXY. So I can see that, okay, angle X, angle C, fine, those are the same. That's given. Also, because they both share angle A, I'm going to say again, angle A is congruent to angle A. Because that's shared. Those are the same. Then I can say triangles are similar because of AA. And of course, what I'm trying to prove is this. So if I throw it down here, again, that's CSSTP. And by the way, these are part of the notes. So the notes should go by pretty fast. Yeah, good. It just depends. It just depends on what you're given and what you're asked to prove. All of them, every proof is unique. So just we'll as we go deeper and deeper in proofs, we'll start seeing sometimes you could do it actually faster. You don't have to do it this way. Sometimes you could, like this case, I kind of had to do all 4 of those steps. Sometimes you gotta have more steps if you want. If you want to be more detail oriented, you could be. It's really the bottom line is that you want to make sure the flow makes sense. Like for example, if you're writing so you're writing an English paper, right? Some people like to write 3 or 4 pages to get their point across. Some people get their point across 1 page. But you just have to make sure that there's a logical flow. That's what matters. Okay, here, another question. Yeah. Which one? They're not the same, no. Because they're asking for different things. Sorry, what was given was different. The given information was different. That's what was different. The given, right. Correct. Okay, let's move on. For 358, let me put the answer key again. Here we go. Okay, so ABCD is the same as EVOL. If you just have to go based off looks, I suppose that's not really the best way to do it, but it does look like E and A match up and B match up, so we go in that order. Likewise with part B. Actually, in this case, you do have the markings, so that helps. The markings help tremendously. So you see RI and ES line up, LA and GH line up. Fine for C. Notice that angle T and G are the same. A and D are the same. And of course, you can say DOG and ACT. So this is old stuff. You guys should be fine with this. You guys should know how to find missing angles. That's not hard. And then of course, these are gonna be similar because you have a pair of angles that are the same. Once you know the side lengths, then you know there's a proportionality. For example, small goes with small, medium goes with medium, big goes with big. So if you want CT, CT is big, PI is big, right? So we gotta go with both. 8 over CT, 12 over 15, boom, you got it. So we're good there. Okay. And the triangle similarity, pretty easy, CAT, PGI. Lastly, are these similar? If you look at the ratios, small to small, big to big, or small to small, medium, medium, up to you. They do want to be in the same thing. So that works. And because angle L, A and L are the same, there's a similarity. You can say side angle side similarity. Okay, we're good? Cool. All right. All right, that covers the homework. Let's now move on to the rest of the notes on 322. So we did the proof up to page 2. And by the way, on page 3 of the 3.22 notes, this is homework ready. We already did this. So let's move on to, actually, was that homework 2? Yeah. Oh, wow. Okay. So there you go. So actually we can start 323. That's nice. Yeah. So actually the notes for 322 was your homework. So yeah, let's move on to 323 then. Perfect. And here's what we'll do. After we finish this, I don't know if we have homework for this topic. Maybe we do have to look. Oh, there's a delta math. Okay, so I need to get that from Mr. Davidson. So it'll be a delta math. If we finish a little early, you guys could sort of just relax a little bit because if you have a test to study for another class, like Reagan said, you have 3 tests this week. Yeah. So if we finish a little early, so we should finish by 10:35. I can probably get notes in the next half hour. So last 15 or so minutes, you guys can use that to prepare for another class or anything like that. We do, it's just I don't know what a delta math is. Yeah, because Mr. Davis is supposed to publish it, and I need to actually let's see if he has it right here. Hold on. One more. Yeah, he's not published it yet, so. Oh yeah, great question. Okay, so the quilt grades, I have not started. I will start today. I'll try to get them done by tomorrow evening. So by Wednesday, you guys should know your quilt grades. And then you'll know whether you're eligible for a retake for test 1 and test 2. Test 2 you already know because the grade's right there, but the project quilt grade actually will go towards test 1. So if that puts you over 80% for test 1, then and you're over 80% for test 2, then you don't need the retake because retake is only going to be helpful if you got below 80% on test 1 or test 2. The retake is going to be October 23rd on after school on Thursday next week, not this week, but the following week. I'll email you if you're eligible and you should do it. If you want to do it just for a heck of it, you can. It won't hurt you. But I always take whichever one helps you the most. So for example, if you get like 70% on test 1, but 60% on test 2, then of course I'm gonna help test 2 out. Yeah, we keep the old grade. We always, it's never punitive. Yeah. 2. So we'll have another one in December as well for tests 3 and 4. Sure. No, I do have to grade it. So, I wish I could do that, but I do have to look at it. There's got to be some integrity. All right. Anyhow, that's a story. Here, another question. Yes, go ahead. Oh, let me pass it back. Let me do it right now. I forgot. Thank you for reminding me. I forgot to do it last week. She's right here. Yeah, you guys haven't lost me now.
Right on the line. But the thing is that you can only get up to these.
Trustees. I've been doing one of the first. Thank you.
Oh,
I'm just not eligible for.
Yeah, you had a better day.
I also will tell you, how much your grade, if you're eligible, also how much your grade can improve if you do the retake. So I'll tell you what your current grade is after the project is done.
Take these tests back, or do we get to
You
keep
keep
them?
them. You keep them, yeah.
Yeah, he said we can.
You can keep it. All right, let's get moving. Okay, 3.2.3. Here we go. All right, decide if each pair of triangles below is similar. If so, write a correct similarity statement. I'll do part A. I'll have you guys do parts B, C, D. Then we'll move on to 372. So for part A, I see two angles that line up. So if I think about it, let me redraw them so they're reoriented. Yeah, that's correct. Good job, Peter. So you see ABC. I'm kind of slightly tilting it a little more to the right. Then let's take a look at DEF. Notice I'm rotating DEF like this. DEF. So if I think about it, okay, that's the same as that. That's the same as that. Yeah, even though the sides are there, who cares? It's enough to say yes for part A. The reasons AA similarity. William, you had a question? Yeah. And lastly, how do you state the similarity? Triangle ABC is similar to triangle DF. Okay, do BCD now. I'll show you guys the answer in a moment. Do BCD. I'll show you guys the answers in a moment. Let me pull up the answer key. So guys, try BCD.
What music did you listen to?
Ooh, good question. So a lot East Bay rap, like E40.
Austin.
Well,
East Bay.
Oh yeah, like in the mid 90s, early 90s, yeah, E40. Well, Tupac was big back then, Notorious B.I.G. Dr. Dre, Snoop Dogg. Also a lot of like classic rock from the 80s, like Guns N' Roses, Aerosmith, so Bon Jovi, what's the ones? Old stuff like Led Zeppelin too. So, but we didn't have like all this. We didn't have Spotify. Why not? Metallica. Yeah.
So, and a cute one would be, like, if this number was greater.
Right. Yeah, correct.
Okay.
Yes. Right. Yeah. So it's obtuse, right?
Yeah.
Because the C square is bigger than A square plus B square.
Okay. Okay, yeah. That makes sense.
Listen to whatever is popular, I guess. Or but the thing is that you guys have all this stuff now to like stream music. We didn't have that back then. Like, okay. Oh well. Okay.
Yeah.
Oh, Prince, Michael Jackson, Madonna. Those more I liked. He wasn't as popular the last few years though. Like he kind of, but he was more popular 15 years ago. He had a reality show. You guys are all the same age, roughly.
No. No one listens to you. You guys. I swear on God.
Okay, guys, quiet, please. So let's take a look here. So all these are yes, except for C. C is a no. If you compare the sides, they're not proportional. 4 to 8 is not the same as 5 to 9. Sorry, 4 to 8 is not the same as 7 to 9. Or sorry, let me take it back. 4 to 8 is not the same as 5 to 9 or 7 to 14. 4 to 8 and 7 to 14 are the same, but not 5 to 9. So it's almost. C is an almost, but it's not. Part B is a yes. That side angle side, they share a right angle. So they both have right angles and the sides are proportional. 9 to 12 is the same as 12 to 16. They're both 3/4. And we say it properly, IHG. So if you go from the top down, same thing, JLK. For D, if you're gonna say that's angle, you're gonna say MNS, then you say MTV, or you can say SMN to VMT, that works also. So those are those proportionalities or similarities, sorry. So we're good? Okay, cool. All right, let's keep moving. All right, oh, we'll show you the blank one. Let's close that. Close that. And close that. Okay, so 3, 2, 3. Here we go. Okay, for 372. Sorry. For 372. So find the links to the segments listed below if possible. So if it's not possible, explain why not. Okay. So for BC, okay, hey guys, I'm talking. Thank you. So in order to compare this correctly, remember 12 went with 42, right? 12 and 42 lined up because A, B, C to D, F. So for I'll call it BC, just call it BC, I suppose. So for part A, you're gonna set up 12 over 42 equals BC over 38. Because remember, 12 was AB, 42 is DE. So EF and BC line up. If you cross multiply it, 12 to 38 equals 42 times BC. Now, yes, I will let you use a calculator for a question like this. Don't worry. But if you didn't have a calculator, or if you had a kind of, if you wanted to feel ambitious, you could cross cancel things, right? Like 6 and 21, 2 and 7. So it should be 76 over 7. Which is roughly 10.86.
Did you just do that in your head?
No, I have it right here.
Oh.
Yeah. Okay.
How did that-
Okay. Go and try for part B. There's not enough information.
Wait, yeah, there's space.
No, for the first for part A up above. If you look at the same pair of triangles, so part B is using the same pair of triangles as part A. So for yeah, because you didn't have side DF. Not information because we don't know. We don't know side DF. Yeah, we just don't know. Okay. Okay, but VT and TN can be found. So VT and TN, you're going to use part D of 371. So those, you do have enough information. So figure those out. I'll set it up for you so you know what you're doing. So you're going to say 9 over 11.5. Wait, does that make sense? Yeah, 9 over 11.5 equals 5 over VT.
Because you have to put.
And here 9 over 11.5 will equal 11 over 11 plus NT. So let me just clear the screen for a moment. You'll explain. I'll explain. What's happening here? How long then be?
9. Well, sorry,
11.5.
So you're doing this over this equals this over this.
Wait, so 9 plus 5.
9 over 11.5 equals 5 for the VT.
Oh, wow.
Corresponding sides, right? 9 is here. That's 11.5. So 9 over 11.5 is this. And then likewise.
Someone.
No, we don't know.
I know, but it's like really bad.
This is just so. This is what trying to.
Yeah.
We just said so we're trying to go bad. It's gonna. We established in the summer. So let's still insert this corresponding side. So here, n equals, sorry, this. N S over D. With n and n.
Yeah.
So that's why I say 9 of 11.5 equals 11. This is 11.
And I know.
So let me put back, the pages back. Hold on a second.
Same thing. It's NTTN are the same thing. Yeah, go, yeah. Here we go.
For basketball.
Yeah, so TN, NT, MAG are the same thing. It's just reversed. Doesn't matter.
So go and solve for BT and NT, and we'll talk about 1 minute.
It's being like one go it's like all. What's wrong with you? This is a great idea. I support it.
Take it out. We have, how long do we have till this period ends?
Another half hour.
You know, did you listen to Math Dre?
I drove green on color 3.
Yeah, sounds.
East Bay rapper.
Yeah, I think.
15 feet away.
He was in like Gillette County.
Because there's a hill.
Yeah, I stopped listening to rap. Well, I mean, I still do, but like the newer stuff, of course. Yeah, that's like 90s.
Did you see him in the new War of the Worlds movie?
No, I don't watch that stuff. No.
No, but Mac Dre.
Yeah,
Andre Nicotino.
no. See, like I'm like after like the 90s, I didn't really listen to newer rap. So yeah, they're 90s. Okay, maybe I don't know. I'd have to look at or listen to songs.
You know what Weezer is?
Do you know what? Let's see.
Oh, Pearl Jam, Nirvana, Stone Temple Pilots, Soundgarden. Yeah, those are other ones I listen to.
But it's not violent.
Okay, let me show you the answers. Let me go and clear this. Here we go. Here are the answers. So again, we already did part A and part B. Oh, here we go. So for C, the answer should be 6.39. For D, it should be 3.06. Let me solve that. So, and these are very straightforward, typical test questions. By sometime near the end of next week, we should have more clarity on what the test will look like. Right now, we actually wrote the retake exam, so that's already been done. That'll be on October 23rd. I'll send an invite if you're eligible by tomorrow. No, it'll be during Y period after school. Yeah. If that's a conflict, we could just talk to me. We'll figure something out. And I'll let you know if you're eligible, how much your grade can go up by. Okay. We're good on 372. All right, so we move on to 373. All right, let's do another proof. And we're gonna ask some questions about it below, and then we're gonna do another page and we're done. All right, so 2-column proof. Let's do this. All right.
Yeah.
So statements and reasons. Okay, and then, Maggie, do you ask a great question? How do you know how many steps we'll have in advance? You don't. You won't, unless I tell you. So if and of course I'm looking at the answer case, I know there are 4 steps. But again, it just has to have a logical flow. Like you have to be able to get, and I guess what we're trying to prove here, they're trying to prove they're similar. Fine. So I want to prove that triangle PDQ is similar. The tilde sign means similar. So if I'm saying PDQ, then how would I write the other triangle in that same order? Would I say XZY, ZXY, ZYX? How would I?
Why is it?
Good, YZX. Yeah, good. You have to go in the proper order. Whatever, however you establish the order of the first triangle, you must maintain that order with the second triangle.
2 givens.
Yeah, 100%. Yeah. Yep, there can be. Yep. So what am I given so far? Yeah, so I'm gonna state the font. Definitely I'm given that angle, we'll say angle Q is congruent to angles X. Yep. That's given. And by the way, I could also say that DQ over PQ, what's that ratio? DQ over PQ? 17 to, so what else has that ratio? XZ to, perfect. That's also given. So guess what? Those first 2 steps were already given to you. That's lovely. So now this is actually a pretty easy proof, because if you're given the angles are the same, you're given 2 pairs of sides are proportional, and then angles in between the 2 sides. Remember, there was a theorem, a sassy. Yes, it's a sassy one.
I think we'll sign.
So it's- This triangle,
PDQ. Yeah, actually, hold on a sec. Oh. Oh, you know what? Okay, I kind of shoot. Yeah, I kind of messed this up a little bit. Okay, I messed up here a little bit, guys. My apologies. What I should have said for the given, what I should have said was this. I should have said DQ equals XZ equals 17. My apologies. So you might want to insert step 2, or call it 1A and 1B. My apologies. Sorry if you wrote in pen. I should have been more thoughtful about that. And I have the answer key in front of me too. Isn't that hilarious? Okay, you really should have said that. Then what you want to say is property or division property of equality for step 3. Because you're dividing 2 things that are the same. And then that side angle side. Yeah. My apologies. I messed that one up.
What were you truly given? You weren't given side of fourth, you were just given silence, right?
I don't know, I'm lost.
Property of
I don't
equality.
have a.
Because what you do is you're dividing 2 things that are the same.
I'm actually.
The, like, all the properties.
Let's talk to Davis about that. We
Yeah.
can do that. Like just what they are.
And like the proof, like the.
Well, yes, okay, division property of equality, and actually you have done that. You did that in middle school. When you were solving equations.
I did
No,
not do
no,
that.
you did. What's 2x equals 10? What does x equal?
Do 5.
Okay, so you've done that. You just did division property of equality. It was never called that, but you have. Now, I'm now giving it a name. That's all.
Just got shot instead of.
Yeah. That's all it is. But it's just weird. But to answer your question about the names, yes, I'm more than happy to provide the names. Additional property qualities, property quality, multiplication property qualities, property quality.
So.
But it's just, it was never given a name. That's all.
Wait, I still watching.
You think-
Division property of equality. We have, like, I feel like this-
Yeah, I
like,
mean,
it's so much easier to do that.
yeah,
I have 3 givens and then I just say SAS.
But you have to establish a proportionality though. That's the thing. So here's the thing. The proportionality was not established as a given. So we had to establish it as a step on its own. It's a logical flow. Yeah, I know. I know it's obvious that they're going to be similar because you see it. There's a formality, and that was where I somewhat dropped the ball when I wrote the proof initially. So now, for part B, Cameron says these triangles aren't just similar, they're congruent. It means that they're the same. And yeah, I'd say yes. I'd say Cameron's correct. The triangles are identical. Yeah, I'd say yes. What special value proof indicates just all sides are the same? Yeah. You're told that, or all corresponding sides are equal. So write a conjecture. We could say is that if two shapes are similar and the zoom factor is 1, then the shapes are congruent. Essentially, if all corresponding angles and sides are identical, then the triangles are identical. It's just the scale. There's no, we didn't scale it up. Correct, right? The shapes were not scaled up or down. Sure, yeah. That's what it means. Yeah. So, yeah, so there's no transformations, there's no dilation, none of that stuff. Okay. Questions? So again, the triangles are identical. They weren't just similar. They were more than just that. You had a question or?
No.
No, okay, good. All right. Last page of notes, and then you guys can then just use your time wisely. Yeah, yeah, no rush. Yeah, okay, we're good. Okay.
Did you say we were doing this on our own?
No, no, now we're gonna move on to part C. Sorry, 374. Okay, for 374, here we go. So Cameron has a new challenge. He drew triangle VTM and SN intersects the sides, dividing in that way. So that B times A equals D times C. He asks, are these parallel? Is this parallel to this? Okay. How do you know? So here's what we're gonna do, guys. Quiet down, please. Thank you. So let's draw the big triangle. Okay, this is the big triangle. T, V, M. Here's a small triangle. N, S, M. And we know this is A plus B. C plus D. And that's A. And that's C. So how do we prove this statement here? How can I prove that's a true statement? What can I do?
Given that what we say,
We do, but it's just from an algebraic perspective. Here's what I want you guys to do. Let's break off the left side like this. This is something that you guys probably don't think to do, but it actually does help. So let's take a moment to think about that.
Okay, so A plus B over A, C plus C over C. Now, obviously I'm comparing this side to that side, this side to that side. I don't know if it's similar yet. I don't know, right? Just comparing this side to that side, this side to that side. I'm assuming it's similar. I'm assuming that, but let's find out if that's gonna be careful. This statement, if you think about it, A plus B is being divided by one thing. C plus C is being divided by one thing. You're allowed to break apart fractions. Because if you think about it, if I have two fractions with the same denominator, how do you add fractions with the same denominator? You just add the numerators, right? Like, for example, what if I had 3/4 plus 1/4? That's 4/4, right? I know that. Likewise over here, C over C plus B over C. You're allowed to break apart fractions. You usually don't think to do it that way. I know you'll see this, and you know to write this. If I showed you these two fractions initially, yeah, same denominator, let's combine it. Same denominator, let's combine it. But I'm breaking it apart. Why? Because what does A over A reduce to? What does C over C reduce to? Okay, that's good.
Oh.
All right, there was just the one.
What's happened?
Yes, you missed you missed the epiphany, but just kidding. Well, I'll explain. All right, let me move it. Okay, so now I know this is true. 1 plus B over A equals 1 plus D over C. What happens to the ones on each side? They cancel out. So now you're stuck with B over A equals D over C. The next step will be to cross multiply. If you cross multiply, and very important, we got to pay attention to what was said earlier in the problem. If I cross multiply, so I'm going to lasso B with C, do pink here, and lasso A with D, then BC equals AD. Well, here's the thing. Is that right? Yeah, BC equals AD. Wait. Well, now I'm confused. Give me a sec here. Oh, that was given to us. Was that given to us? Yeah. Hold on. Oh, because you said that earlier on. Because it was divided. Wait. No, I don't know why I'm cross multiplying now. Oh, yeah, now I got it. No, I got it. We're good. Here's the reason why. Cross multiply made no sense, guys. My apologies. This is true because SN divided MV and MT in a proportional manner. Okay, let me draw a triangle one more time. And you'll know why. We had the big triangle, right? Here we go. And when you drew SN, you drew it deliberately to devise proportional. It was done on purpose. And we knew that VS was B. And we knew SM was A. And we knew this is D. And we knew this is C. So we divided in such a way where we deliberately wanted
this fraction, b over a, is the same as b over c. And because that's what I have over here, that's why I know that's it. So it wasn't cross multiply, that was confused, so I apologize about that. So how do I, true, because SN divided MD and S with proportional math. You were told that right from the beginning.
Wait, is that the answer number two?
Not yet, we'll get to this in a second. But, yeah, so, yeah, if I broke apart fractions, cross off the ones. This is actually the true statement. It's not, doesn't seem very obvious, but if you look at the triangle here, this to this is the same as this is, but we did it on purpose. This was done on purpose to break apart. So for example, what if I had like 2 and 4 and 3 and 6? Of course, I'm doing it in such a way where 2 to 4, 3 to 6 is the same ratio. You're doing this on purpose so that these side lengths are in the same ratio. It's done on purpose. So that's the reason why we can prove that.
Then, just to finish off the notes here, are the triangles similar? Of course. The answer is yes. Because of side angle side similarity. So let me draw a triangle one more time for my purposes. You guys already have it. Here we go. So V, P, S, N, M. Okay. Again, that's B. That's A. That's D. That's C. So will SN and VT be parallel? The answer is yes. And that's because the corresponding angles of similar triangles are congruent. So for example, angle TVM will be congruent to angle NSM. And when that happens, corresponding angles congruent, then lines parallel. So since that is the same as that, then those must be parallel. So this is kind of helping you to eventually get to more elaborate proofs where you might be asked, hey, is SN parallel to VT?
This is simple. This is elementary. This is,
That's a little more complicated.
oh, this is.
Yeah, no, if you guys are a little confused, it's understandable because this is more just to get you guys trained to do this.
So this is just like enrichment type.
Correct. In a little bit. Okay, so we'll stop there. We got about 8 minutes left. Homework will just be a Delta map. I need to talk to Ms. Davidson about that. I should publish it later today.
We are on computer and we're going to get.
Yeah, will be a Delta map. There'll be a link will be there. All right, we're done for today.
Yeah, I mean, honestly, that was light.